The age of modern technologies is the age of global challenges for those who take responsibility for their business and environment. Modern approaches of production setup require new technologies basing on the neighbor principle, with concern for the environment and urban ecology. Wastewater treatment plant with laminar filtering is meant for implementation of large-scale challenges in production setup. Formation of urban environment, including that of Russian resort cities with heightened ecological standards. A pioneering R&D work guarantees normalizing of various sewages. Vented emission allows having zero controlled buffer area. The system easily fits into any urban and natural landscape. It can even be placed unsheltered if weather conditions and landscape allow. The Laminar bioreactor technology surpasses all the existing sewage treatment systems due to its resource-saving capability and high environmental friendliness. The wastewater treatment facilities already put into operation demonstrate economic benefits because of laminar technique. The wastewater treatment plant is located in a light gauge construction building. It has an automated process control system, which includes sludge dewatering and discharge system, and heating, ventilating, and lighting systems. The wastewater treatment plant divided into independent processing lines ensures complete purification of influent water in conformity with applicable standards, even if equipment of one of the lines is removed out of service. It's possible to blow down and perform preventative maintenance of the reservoirs without shutdown of the waste treatment facilities. There was chosen the optimum process layout for industrial sewage treatment. It includes the following stages. The primary treatment plant, with preliminary setting tanks having thin layer modules. Then the sewage goes to the biological wastewater treatment unit with anaerobic and aerobic bioreactors. Sludge flocculates and sets in the humus tank. Further sewage purification is done with electromagnetic, mechanical, and sorption purification filters. 6 sequential bioreactors guarantee effective spatial absorption of microorganisms. The first stage includes mechanical sewage treatment in grit catchers, automated step grates, and primary settlers with thin layer modules. For food factories having strong sewage, there is added mechanico-chemical purification. The unit is equipped with sewage neutralization hardware, electrocoagulators, flotation units, and electromagnetic filters. The next stage is biological treatment, which is performed on parallel separate biotechnological lines. Each such line consists of 2 to 4 successively installed anaerobic bioreactors and 3 to 6 aerobic bioreactors. Microflora of the bioreactor is immobilized on a planar spiral carrier with a specific surface area up to 2,000 square centimeters per liter. The bioreactors have conical bottoms and are equipped with automated sludge discharge system. The discharge is done automatically on a daily basis without shutdown of the waste treatment facilities. Annual preventative maintenance is not necessary. Organic compounds resistant to oxidation are decomposed in the anaerobic zone. Deep bacteriological purification is done in the aerobic zone, including ammonia oxidation. The sludge liquor is aerated via microbubble titanium spargers with the purpose of organic compounds oxidation and water aerification. This technology allows great energy saving due to successful application of the state-of-the-art developments. For example, titanium microbubble spargers reduce volume of air used for aeration. This allows using less powerful blowers. The size of an air bubble obtained from the sintered titanium powder is 100 microns, which is times smaller than produced by a regular oxygenator. So using titanium aerators allows 3 to 5 times energy cost reduction. After the humus tank, the treated sewage goes to buffer tanks. Therefrom, they are ejected with a submersible pump to the tertiary treatment unit with automatic mechanical cleaning and sorption purification filters. Automatic washing is done to rinse contamination off the filtering material and regenerate its properties. The rinse water, as well as the product water from the filtering press, returns to the stabilization tank via pipes. When rinsing is over, the filter automatically comes into operating mode. Ultraviolet disinfecting units are used for effluent neutralization. They are equipped with scrubbers for cleaning of UV lamp surface. Ultraviolet germicidal rays are environmentally friendly and effectively control viruses, bacteria, and protozoas. This method ensures compliance with requirements applicable in the Russian Federation. The sludge from the primary and humus tanks, as well as from the bioreactor, goes to the sludge pit via pipes or due to the hydrostatical pressure. Therefrom, it is ejected with a submersible pump to the sludge dewatering unit. The sludge, together with the flocculant solution, is pumped to the thickener. The flocculant is pumped out of its plastic container with the flow control pump. The dewatered and decontaminated sludge is loaded on the leak-proof dump trailer and carried to the industrial solid waste disposal site. The dewatered sludge falls into the fourth substance hazard category. Monitoring of the microbial flora generation process is a proprietary know-how. The proposed innovative solution is a cost-effective investment project. It may be commercially profitable in 3 years of service. The Laminar bioreactor allows 4 to 5 times reduction of service charges if compared to traditional technologies of the last century. This plant requires a short assembling period because of the off-the-shelf industrially produced equipment. 8 vessels of the bioreactors are made from polypropylene, thus being highly rust-resistive. They are easy to maintain, as replacement of faulty units may be done without process shutdown. The plant is suitable for strong sewage high-level treatment. Opinions of environmental research officers and experts in the sphere of disposal facilities are later on. As for efficiency, it's beyond any doubt. I'm familiar with this technology. I've seen this wastewater treatment plant in operation. I've closely scrutinized this technology. The greatest virtue of this facility, as I see it, is, first of all, operational versatility of the tanks, designed by the Research Institute. The same units may be used for wastewater primary treatment, their preliminary sedimentation, for biological sewage disposal, and as bioreactors. As well, they may be used as humus tanks. Thus, most of all, I like flexibility in the use of the reservoirs, patented by the company. I see that each year the company markets something new. It means that the company progresses. It's alive and forges ahead. I think this technology is the most effective for purification of effluent coming from a human settlement, where manufacturing facilities are represented by food industry. This technology is very effective and allows not to build waste treatment facilities in a day for further extension, as it is required by regulatory documentation, but to gradually ramp up facilities without any massive reconstruction and reworking of the water disposal system. This is the preeminent advantage of this system. Therein lies its advantage. All the units of the sewage treatment station are located indoors, so we're able to collect all the miasma, or gases that might be generated during treatment, in a single place, and decontaminate them. Respectively, these sewage treatment plants may be located not in the suburbs, but in the city itself. This is the great benefit. Yes, I'm familiar with this technology. It embodies proprietary patented improvements of the well-known equipment. The improvements are used on different stages of this technology. This technology implies that each treatment phase is done in a separate plant. These plants operate indoors. So we have an indoor plant technology. This is an obvious advantage of this technology. Why? There is no direct contact between the treated sewage and its sludge with the ambient air. Before the contaminated air is emitted into the atmosphere, it is purified. Thus, not only sewage is treated, but the air that gets contaminated in the process of sewage treatment. This is an obvious advantage of this technology. Besides, there is still another advantage. I mean, the plant occupies rather a small territory. The space required is significantly less if compared to the existing wastewater treatment plants. I mean, the area occupied by the waste treatment facilities. One more advantage can be mentioned, as far as there is no direct contact between the outdoor air and the aerial environment generated above the waste treatment facilities and the sewage sludge. It is possible to say about foreseeable reduction of the controlled buffer area around the waste treatment facilities.
Можно говорить о предполагаемом сокращении санитарно-защитной зоны вокруг очистных сооружений.
We should also briefly touch upon pros of this technology. Flexibility of this technology allows considering all the inputs, making it applicable both for industrial and household sewage treatment. Besides, this system can be accommodated, if compared to a regular wastewater treatment system, on a smaller territory. Furthermore, there might be possible reduction of the buffer area surrounding the territory occupied by the wastewater treatment plant. Besides, the treatment cycle is almost completely automated. It makes it possible to control treatment process and adjust it at the stage of system installation in order to fine-tune the wastewater treatment plant in conformity with definite inputs. As well, the system remains adjustable afterwards, being already in use. In a year or 2 or 3, in one way or another, control allows to identify defects and make them good. Broadly speaking, the technology under discussion can be considered an advanced technology for this type of intended function, because it does not occupy large territory of a gated community. It can be located in any convenient place for this gated community.
Она может быть расположена в любом удобном для коттеджного поселка месте.
It is easily monitored. As the process is completely automated, there is a possibility to control and customize the system in case inputs change. What else? Needless to say, this system is not that expensive as regular wastewater treatment plants. Besides, the controlled buffer area for this system is considerably smaller than for a regular wastewater treatment plant. It is one of the modern innovative technologies which our researchers examine. It was recommended for deployment in several constituent entities of the Russian Federation. It is called the Laminar bioreactor effluent purification technology. We consider it deserves consideration of the municipal facility owners and project managers. The reason is the following. It allows dealing with environmental challenges, gives answers to issues regarding energy efficiency, as well as issues regarding making the best price-quality decisions. We consider a great future is reserved for this technology. In the Russian Federation, low-rise construction is rapidly growing. Low-rise houses use individual septic tanks. We recommend horticultural societies and tenants associations the optimal decision. A local effluent purification plant. Sewage disposals shall be at industrial production facilities as well as in settlements. This calls for cost-effective and environmentally friendly technologies. One of them, from our point of view, is, as we speak, the Laminar bioreactor. Production gets into full swing. There started refurbishment and retrofitting of our production facilities. Highest-level leaders pay paramount attention to production ramp-up within the import substitution program. But regard should also be paid to all the associated initiatives required to organize modern manufacturing facility. Respectively, only modern technologies shall be taken into consideration. I mean, waste disposal management technologies. Thus far, conventional waste treatment facilities fail to provide fine purification of industrial wastewater. It is clear that research institutes are not sitting tight, but looking for optimal water treatment technologies that would make it possible to use treated water for watering or even draining into open waters. What do I mean by wastewaters? Metabolic byproducts, as well as process waste and private household wastewaters. It would be safe to assume that our specialists consider it to be an energy-efficient technology, a Lego-type system, easy for routine maintenance. Usually, the main problem is operating costs, but our cost controllers have calculated that in case of this system, there is a considerable cost saving during operation. Anything has its production cost. Among other factors, operating costs lead to increase in production cost of any product manufactured on the territory of the Russian Federation. Utility costs have been one of the nagging problems of the past 10 years of rampant importance. In view of this, we welcome and recommend to implement technologies ensuring saving during operation. Southern regions have been rapidly growing over several decades. Traditionally, population boom happens due to migration of the people from the north to the south, to the southern federal district. For this reason, utility system and community facilities were not ready to receive such a load. There have been hardly any new effluent purification facilities built lately. The old ones were run ragged. In the southern federal district, there are several seas, the Black Sea and the Caspian Sea. In general, the water contamination level is off the scale, especially during the heat in summer. Growing of child skin, respiratory, intestinal diseases is caused by direct discharges of untreated wastewater into the deep sea. It is critical for the regions with surging economy. For these regions, we have recommended to test and perfect the new technology in major cities with a million-plus population. And then, on a downward spiral, the system will be implemented in the settlement-type municipal entities. Without question, our seas will be cleaner. Another strong positive effect of the above-mentioned technology implementation is treated wastewater reuse for irrigation. We have a possibility not to dump stabilized sewage into the deep sea, but to use a purified effluent for watering farmland. Here we get double profit. Operating costs reduction, plus potential efficiency gains for farmers, lowering of irrigation water costs. Businessman opt. Ministry of Nature and Environment recommends. The Laminar effluent purification technology is an innovative response to the challenges of the new era, with concern for environment. Research and Design Institute of Environmental Problems.